Welcome to another problem for star delta. Now in this circuit you can see there is a complex circuit and we need to find out the resistance between A and B. That means we need to find out the equivalent resistance between A and B. So you can see in this circuit there are many star and deltas, and if you will not carefully observe which delta or which star to decompose, then to get the answer it will take a lot of time. Okay, so here you can see there are many resistors having resistance value given 3 ohm. Now we will go step by step. First we will think which delta we need to decompose here. Now we have redrawn the diagram again in this page. You can see I have given the node number. So this node is A, as you can see, and this node is same. So I kept the name is B, and here this node I have given, this is the node C. So this node is D, this node is E, and this node is F. Now once I gave the number, then I can say that which delta I will decompose. Okay, so now let me so first I want to decompose this particular node. I want to decompose this particular delta. So okay, so this is delta 1. Okay, so when I decompose delta 1, I need to find out delta 2 star formula, how to convert delta to star. So first I will draw the delta 2 star. So if I will decompose this delta into star, I will get a diagram like this. Okay, so once it will decompose, this portion and this portions will be removed. Now you can see each value of resistance is, so R value is 3 ohm. If you want to find out, this is R1, this is R2, and this is R3. So I can find R1 equal to R2 equal to R3 equal to R by 3. That means whatever the new star I got from this delta, so each resistance value is 1 ohm. Okay, now I need to draw the another diagram by removing this delta and keeping this star. Now you can see here, after removing this delta, so here I got, this is 1 ohm, this is 1 ohm, this is 1 ohm, and this is 1 ohm. And you can see here I clearly given the node number C and B. The C, E, D, E, F, the rest of the diagram is looking as it is. You can see here. So C, E, D, B, F, so they are looking as it is. Now you can see there are more deltas. So here you can see another delta, like this is delta 2, this is your delta 3, this is your delta 4. Now which delta we will decompose so that our computational effort will be less. So in my opinion, I will go for the delta 2. So I will go for the delta 2 and I will decompose that delta into star. When I am decomposing, I will keep this node number same. So I will take this, I am taking different color for C, D, E. So for this C, D, E delta, I will make it into star. So let me decompose here. Let this resistance value will get R4, this is R5, this is your R6, and you know that this value is R, this value is R, and this value is R, which is having 3 ohms. Now when I will decompose delta to star, I can find out the R4 value, R5 value, and R6 value, all are having same. So I can write down, this is R by 3, that is 3 by 3 is 1 ohm. So now I got R4, R5 and R6 having 1 ohm. So when I convert it into delta to star, then in the next step I will remove all these node and replace, instead of delta I will replace the star. So I will go to the next diagram. So now in the next diagram you can see here, I kept this nodes C, E and D here, C, E and D here, and instead of delta I will replace here the star, which is having resistance value 1 ohm, 1 ohm and 1 ohm. Now I will go for this delta. To remove this delta, name is delta 4. I will go to decompose this delta 4. Now you can see here, this delta I can decompose into another star. So I will put it in another color. let, so previously we know that this resistance values are, this resistance values are, this resistance values are, and from this delta what star I will get, I will name this is that, let this is your R7, this is your R8, this is your R9. Okay, so when we convert delta to star, again I can get the same answer, R7 equal to R8 equal to R9. So both having same value, that is 1 ohm. So once I will convert delta to star, then there is no use of this delta. In the next diagram we will remove this one. So after remove this one, I will get a diagram like this. So you can see the node C is here, E is here, and D is here. Okay, so in between C, D, E, where there is a delta was there, I change the delta into star. So I will get 1 ohm, 1 ohm, and 1 ohm. When I remove this delta 4, when I remove this delta 4 to star, here also I will get 1 ohm, here I will also get 1 ohm, and here I will get 1 ohm. Now E and F node is kept as it is. Now you can see here, now this diagram looking little bit simpler. Now you can see this 1 ohm, this 3 ohm, and this 1 ohm are in series. So they are in series. Okay, so this 1 ohm and this 1 ohm, they are also in series. Now if I want to redraw this diagram, you can see I kept these nodes as name as A and B. So from A to B, let this new node is N. Let this new node is N. So A to N. So I can see, you can see here A to N. I have kept resistance value is 1 ohm. You can see A to N, the resistance value is 1 ohm here. Then N to C, N to C, that is 1 ohm. So this is N to C. So I make this is the C. So N to C is 1 ohm. Then again, so I'll keep this node, new node is N2. So C to N2, C to N2, this is your N2. So C to N2 also 1 ohm. Now N2 to 1, N2 to, so this is, let this node is N3. I'll keep this node name is N3. So if I'll keep this node is N3, so you can sort N2 to N3, there is two 1 ohm resistors which are in series. So this is your N3, I'll keep as this is N3. So N2 to N3, two resistors having 1 ohm are in series. Now you can see, as I told, in between N2 to N3, this 1 ohm, this 3 ohm, and this 1 ohm. So all are in series. So I kept like this 1 ohm, 3 ohm, and 1 ohm in series. Now this 1 and ohm again in series. Now what left here? So in between B to N3, you can check here, this is the node B, and in between B to N3, this resistance value is also 1 ohm. You can see this resistance value is also 1 ohm. Now this diagram looking very simpler. Now you can see this 1, 3, 1, they are in series. This 1, 1 are in series again. So both will be in parallel. So now I can write down. So by taking this I can write down this value is 3 plus 1 plus 1, that is 5 ohm. So now this 5 ohm is parallel, this 5 ohm is parallel with this 2. Okay, so 5 ohm is parallel with 2. Okay, so I will get the value 5 into 2 divided by 5 plus 2, I will get the value is 1.42 ohm. So up to this, now I will get the value is 1.42 ohm. So now this 1.42 ohm are in series with this 2 and 1. So now the new resistance value I will get 2 plus 1.42 plus 1. So I will get here 4.42 ohms. Okay, so if we will write down like this, so up to this I will get 4.42, I will get 4.42. Now you can see 4.42, so the total resistance in this green color are in parallel with 1. So 4.42 are in parallel with 1, then that is series with 1. So I can find out the R equivalent equal to, so 1 plus here you can see 1 and 4.42 are in series. So I will get 1 plus 4.42 plus 5 divided by 5.5. I will get the value here 1.815 ohm. I will get the value 1.815 ohm. Okay. So from this I can tell that this RAB value is 1.815 ohm. Okay. So I hope this analysis can clear your doubts. If you think that this uh, numerical is helpful to others, then you can share the video to others. Thank you for listening.